Thanks coming for the tutorial 9 in the mechanical of solids. As we mentioned, this one is based on stress formation. And of course, there's many ways to do the work, but we most care about for the Mohr circle. Okay, we see all the topic first. So we see the first question. So the wide flange beam is subject to the 50 kilonewton force. Determine the principal stress in the beam. So at the point A, so located at the wave of the bottom here. So at the bottom of the up flange. Although it's not very accurate, so use the shear formula to calculate the shear stress. Okay, so this one will give you ask to focus on the shear stress first. So why we ask to work on this? Because we know from the equation, so we know the principal shear stress will be sigma 1 or 2 equal to half sigma x plus sigma y plus minus square root half sigma x minus sigma y square plus tau xy square. So of course we should know where's the tau. Okay, that's the easy way we should work out. So while from here we use ask to use shear formula. Shear formula based on this tau equal to VQ over RT. Okay, so that's why from here we must get some basic idea. So we should work out. So that's why from here I just use the pen to show you. So we work on here, we should know that tau is equal to VQ over RT. Okay, but here's A, that's why we use A to replace. Okay, that's a point. Okay, so that's what from here that we know, that's from the shear formula. Shear formula, where's V? V, of course, from here, we should know where's V. So that's why we combine all the things, use the method of section. Okay, so where's method of section? We cut from this way and we look for another one. So otherwise we can save time, we can work on these things. So this is for 50 kilonewton. We cut, remember here's 3 meters. We cut, remember we mentioned we cut left from left hand side. So then here the V upwards is a positive value, and the moment was positive value. So this one we did in the lecture 2, and also in the tutorial, and also in the mid-sem exam. So method of section, please change this one. In the final exam, definitely this question will be shown up again, but different question. Okay. So basically here, of course, we can work out this method of section. Then we can work out V minus 50 here equal to 0. Okay, V is positive. Okay, so V is equal to 50 kilonewtons. So from here we get a V here. So the V will get it. So next one we can work on the I, Q, we should work out. But we still work on the moment, okay? Because sometimes we need a moment. Because sigma, we should know for the moment. Moment over here mentioned to you, was always mentioned to you. So here the negative M plus or minus, because all were clockwise, as a minus 50 times 3 will equal to 0. So M will be equal to negative 150 kilonewton meter. Okay, so from here we can work out. So of course this one we use later on. But we from this equation we must focus on I. With I. So of course from here this one is I beam. So we can put this thing the big block minus small block. Okay, so from here this width is a point. Is a 0.2. Height is from here is a point 0.12 plus 0.25 plus 0.012. So that will be equal to 3274. Okay? And for the small one, so this will be 0.2 minus 0.01. So that's 0.19. So the width. That's why from here we can say 1/2 BH. B is a 0.2. H, so 0.274 cubic minus 1/12. B is equal to this value, 0.19 times height. That's from the 0.25 cubic. So this is what we did many times. I will not give more details of this way, okay? So of course from here we get a number 95.45 times 10 to -4 meter per 4. So that's about Q. I will work out. That means I will work out. Okay? So where's Q? So QA. So where's QA? I'll repeat this one again. So as we mentioned in the lecture, so this one's from the point to the earth surface. So from here, so that's why from here we can see, we can draw this thing relative to, come to here, this one. Remember, this is the halfway, NA. Okay? So of course, this one, on here, we only have this one. Clear? Because A is on the bottom. So of course, based on this one, we'll put everything here. So QA is Y bar times A. Where's Y bar? Y bar coming here, you can see, everyone look on the screen here. So this one, we should say the center of the cube. How much of this one? Okay, we know this one, this height, is a 0.012. Okay, this one is a half of the 0.25. So that's why from here, this is a middle way. So that's why from here is a 0.125 plus half of this one, 0.06. So that's why from here we get the number. So this one is equal to 0.131. So that's the distance for the red color. So from here, we can put here is equal to 0.131 times the area. This area is a 0.2 times 0.012. So you can get the value is 0.3144 times 10 to -3 cubic. So from here, we can get it QA work out. Okay? So then we can put the order D because it's a simple way for us to work out. So from here, we can work out. So you can see the tau A is equal to VQA over IT. So put the values in. V is 50 kilonewton. So 50 times 10 power 3 newtons. So the QA, which is work at 0.3144 times 10 to -3 cubic divided by I, which is work out 95.45 times 10 to -6 meter per 4 times T, of course, that's the, as I would say, this is width. So how much? Of course, it's 0.01. So of course, the value is equal to 16.47 megapascal. Okay, so this we combine all together. So after we know this one, we still should know the tau. Tau will work out. Then we'll work on the sigma. Sigma is on that direction, transverse. Okay, so the sigma A is equal to So negative my over r. So we learned this one before. Equal to negative m, we just work out is negative 150 kilonewton meter. Y from here is above, so it's half of the 0.25 meter over I, which is work out 95.45 times 10 to the negative 6 meter per 4. Okay, so of course we get the number is equal to 196.43 megapascal. We work out because sigma A, this value is positive. So that's why I can write down sigma S is equal to 196.43 megapascal. Sigma Y, no sigma here, is 0. Tau xy is equal to here. Tau A is on this way, on the top. Okay? This is a little bit tricky because from here we cannot get an exact number, whether it's a positive or negative from here. But we'll still write down here. Could it be positive, could it be negative? Okay? So that's 16.47 megapascal from here. Okay? So then we can write down sigma 1, 2 will be equal to half sigma x plus sigma y plus negative, remember here, square root, half sigma x minus sigma y square plus tau xy square. Remember sigma y should be less than sigma 2. Remember here the sign plus negative here. Also you can see there's a tau xy here, doesn't matter because here will be square. Okay? So that's why we can put all the values in. Is half 196.33, so plus 0, so plus minus half sigma x 196.45 minus 0 square plus tau xy 16.47 square. Okay, so you can see sigma 1 will be equal to 198 megapascal, sigma 2 will be equal to negative 1.37 megapascal. Clear? So this is just the way to work out by equation, but it's all come together. You will see for this question, we didn't provide the sigma x, sigma y, tau xy. What should work out by yourself? So, but all these things were based on the previous knowledge. So that's why this topic could be hard, could be easier. So it depends how solid you have the basic knowledge. Okay? So just for this topic, so we can get this idea. So we should work out the tau xy, sigma x, sigma y from our previous knowledge we can work out. So that's why many things will come back together. Okay? But this is basically for you to get the skill for you to work out by using the equations of sigma 1, sigma 2. From here we can work out. So of course this one is a very basic thing for you. Okay? But most thing we will use Mohr circle. Mohr circle is the most difficult thing. So we can see from this question. This question is very similar to the lecture examples. So from here, so we can determine the principal stress and also maximum in-plane shear stress and average. So this is very similar, okay, but this is very similar to the example 5 and exercise 1. Okay, but they combine together. So lecture 5, example 5 will work out the principal stress. Exercise 1 also work out the maximum in-plane shear stress. So that's why from here we combine all together. But the key thing will be the same, okay? So basically we can see from here, this will only give you a stress state. So for shear stress, for this thing, you so say, hey, this one, which one is which one? We should get rather value. I say, for the first step, we should write down the sigma x, sigma y, tau xy. Okay, we work together. Okay, we work together. Everyone, we work together. Okay. From the stress state, sigma x, how much were there? Work together. Sigma x is equal to how much? 100 tension. Yeah. So 100 megapascal. Sigma y, how much? How much? 20 positive, negative. Why positive? In tension. Yeah. So 20 megapascals. How about the tau xy? 40 megapascal. Why negative? Because the right hand vertical is a downward. So that's why from here is a negative. Okay? So this is very, very important. You put the wrong thing, this one wrong. So that's why this is basic thing for you to get the things. That's why it's negative sign. Clear? After we know this thing, then next step we should work on the center of the circle. Okay? So, in center of a circle, we should work on a sigma average. Is half sigma x plus sigma y equal to half 100 plus 20 equal to 60 megapascals. So that means the center C, that means sigma average 60, 0. Okay? You must write down this one because I get a mark. Clear? Then we should find a reference point. A, how much? Sigma x, tau xy. Also get a mark, okay? The next step is a reference and a radius. Radius is equal to, as I said, they can use the distance CA. So that means the point CA, that means it can go to x, 1, 2. So 100 minus 60 square plus negative 40 minus 0 square. So the distance, get the idea? You can get the number is equal to 40 square root 2 megapascal. You can write down to calculate. Or you use the equation, okay? R is equal to half sigma x minus sigma y square plus tau xy square. We can put the values in. Half sigma x 100, sigma y 20 square plus tau xy minus 40 square. Still you can see the answer is the same. Clear? It's the same. As I say, you can use either way to work out for the R. After you know center of the circle, reference of the point, you know the radius of the circle, then you can draw the Mohr circle. Okay? So now we can draw the Mohr circle. I just used to want to draw this thing. Okay? So then we can draw the Mohr circle like this way. Sigma from left to right hand side. Clear? Y is a tau xy. Sigma. Okay? You can write down by yourself. I didn't put it the correct way. Okay? Just put it here. So for example, it's a 1, 2, 3, 4, 5, 6, 7. I put something here between each of them, small one. Let's say this one is a 60. So 1, 2, 3, 4, 5, 6. So this is 60. 1, 2, 3, 4, 5, 6, 120. I put something like this. And also we can do the same way. Okay? So we write down this one, the center C is here, 60, 0. Okay? C. 60, 0. And the radius, how much over here? This 40 times 1.4. That's something roughly 80 something. Okay? So roughly 1.44, 56 something. Okay? So roughly 56. You can work out by yourself. Now you can see the radius roughly is here. So the circle, so roughly like this. The circle. Clear? So then, of course, we can let's say radius. So let's say 40 root 2, some roughly 40 root 2. You can work out, okay? So then, of course, base is R. What's the radius? This is a reference. The reference point is 100, negative 40. 100. So that's the point. 7, 8, 9, 10. The point is here. So there's A is here. 100, negative 40. Okay? So that's why from here we can see A is here, CA. So we'll write down here. This is R. This is R. Or, sorry, sigma average from that point. So that's why from sigma 1 we can work out. Sigma 1 we can work out. Sigma 1 is here. It's a sigma average plus radius. So that's equal to 60 plus 40 square root 2. So roughly 170 megapascal, roughly. Sigma 2 is equal to sigma average minus R. So roughly 60 minus 40 root 2 equal to 3.43 megapascal. Clear? So that's what from here we go. Of course, we can get the values here. This is angle we can work out here because it's sigma 1. So we can see from here the angle is here. Look here, the angle. The angle is 2 theta P1 because the sigma 1 is here. So of course from here we can see this one is a tangent. 2 theta P1 is equal to how much? This one is a height. How much? Height is 40. Because it's 40 here. Divided by the length. Length is 100 minus 60. So that's equal to 1. So that means 2 theta P1 is equal to 45 degrees. So the theta P1 is equal to half of 45 degrees is 22.5 degrees. So this is here, come to here. So this is clockwise. Clear? Because we go to, this one is a positive, this one is negative. That's why it's a clockwise. Clear? So now we can draw this one. You see, this one is something like this. Okay? So sigma 1 and roughly the angle, okay, is 22.5 degree. Okay, because this one is horizontal. Okay, this one is a sigma 2, sigma 1, both positive, that's why tension. Okay, so then we can also work out the tau max in plane equal to plus minus r, so equal to plus minus 40 square root 2, so roughly plus minus 56.6 megapascal. So that's why from here, this point or that point. So that's an E or F, something like this. How much we can work out? We can still use this one to work out, come to this angle. Because this one go to P2, that's why here, the angles here, that's why is 2 theta S2 here, because close to tau 2 here. So again, we can work out tangent 2 theta S2 equal to how much over here? This one is about, this value is 100 minus sigma average. So equal to 100 minus 60 over hat is 40. So equal to 1. So that's 2 theta S2 is equal to 45 degree. So that's 2 theta S2, sorry. Theta S2 will be half of 45 degree is equal to 22.5 degree. So this one move to this. So that's why it's a counterclockwise. Okay? So the mention this one must have same direction. Counterclockwise is a positive value. So that's why from here it's a positive value. So that's why from here we can draw this one. Okay? We can draw this one will be like this way. This is X, this one come to here. The sigma average, okay? Is right on the value. And then the direction will be, this one will come to here. Sigma average. So that's 22.5 degree. So that's from here, I can draw this kind of figures so easily to work out. So that's the part for us to work out. So use the method of a Mohr circle. So we can draw Mohr circle, we can work out very easily, okay? So that's why from here we must know how can draw Mohr circle. If you know how can draw Mohr circle, you can get the value very easily. Okay? I don't expect that you get everyone get a full mark of this question, but at least you can draw the Mohr circle, you get a lot of mark. Okay, that's a simple way for you to work out. Clear? So that's what basically thing for you. You get this idea how can draw these things based on the way we can work. Also the radius, we use the two methods. You can work any of them, you can get the answer. Now let's just put an equation. You can see from this equation we can work very easily. Okay? So that's why from Mohr circle, I will not repeat over this because we mentioned this one in the lecture. So you can do all of them, you can work out. I will not repeat over this. You can read it by yourself. Last one, this question was last year standard final exam question. Okay? So everyone should realize if I put some real question for you, you should get the idea how it can work out. This question was last year standard final exam question. Okay? We can see the question here. The rotor shaft from here of a helicopter is subject to tensile force and torque shown here You can see the torque and the tension here. When the rotor blades provide the lift force to suspend the helicopter at the mid-air. So let's have a load, have a rotate, okay? So if the shaft has a diameter of 150 millimeter, that's the diameter of this one, 150. Determine the principal stress and the maximum in plane shear stress at a point located on the surface of the shaft. So this criteria give you the stress state, but you must work out by yourself, okay? You want to work out this thing, we can draw free body diagram, because in a similar way, we can draw free body diagram, we can work out. So, for example, we can draw free body diagram from here. This one you can see from here, you can see this is a helicopter. We see there's a blade. Okay? This one blades have something like a lift. There's a force, 225 kilonewton. So it's in tension. And also this one thing, this one is a rotate. Rotate. You can see this rotate like this way. Rotate. So 15 kilonewton meter. But remember, this one is only for this. When we try to get something here, remember we should use the internal, which is the method of section, to count. So that's why this one, we use one thing to work out. So for example, if we can say this is the y direction, okay? Then of course we can see the internal force. Here is N, clear? And also the torque will be on the opposite direction. So there's a torque will be here. Remember, that's all this external loading, but we put the internal loading. Clear? So that's why from here, we can summate of all the Fy will equal to 0. So that means N minus 225 will be equal to 0. So the N equal to 225 kilonewton. Yeah? Same way we call a moment. So measure of all the moment about y will be 0. So it means t minus 15 will be equal to 0. So that t is equal to 15 kilonewton meter. So of course we will work out the internal load N and also the internal torque we can work out. But remember, where's the values? Where's the torque? Because rotate will give you the way to work on the shear stress we mentioned before. So that's why also will give you the load, and will also give you a load for the normal stress. So that's why we can work on the A. The area of here will give you blades. The blades is a circle, that's with pi half d square. So we can find here the pi half d is 150 millimeter. So that's why I can see that is the value is a 0.15 square the meter. So that's why we can get the value is 5.625 times 10 to the third pi square meter. I just keep the pi here, okay? You can work out by yourself. Now sigma, that's the normal stress, is equal to N over A. Okay? So that's why we can find it here. N will just work out 225 kilonewton, okay? Which will write down, say, newtons. Divided by area, we'll just work out 5.625 pi times 10 to negative 3. Okay, square meters. So you can see the value is a 12.73 megapascal. That's the load. Where's the torque? Torque, we'll go to maximum one, torque max. It's equal to TR over IP. RP, because the circle, as we mentioned, RP is equal to half pi R power 4. Okay? So that's what I put here, the value. T, we just work out, is a 15 kilonewton meter. Just convert into Newton meter. R is the radius, half of the 0.15 meter, divided by RP, which was mentioned, is half pi radius, half 0.15 power 4. So then we can find it here, there's 22.64 megapascal. So we work out all of them. We just write down all the things. So sigma x equal to 0, sigma y equal to 12.73 megapascal. Tau xy equal to 22.64 megapascal. We work out the center of a circle is a sigma average. How much? Half of a 0 plus 12.73 equal to 6.366 megapascal. So that means the center C is equal to 6.3660. So you must write down this one, get a mark. Okay? The reference point A. So sigma x 0, tau xy 22.64. That's point A. Also get a mark. Write down this one. And then the radius R. Do either way by yourself, okay? So like I said, you can use the distance of the point or use the equation. So I know many students want to use the equation, okay? Half sigma x minus sigma y square plus tau xy square. Put the values in. Sigma x 0, sigma y 12.73 square plus tau xy 22.64 square. So you can see that's the value will be equal to 23.51 megapascal. So here you can see we get a center. We see the point, reference point A. We also get the radius. Then we can draw the Mohr circle. Okay? So I'm going to say we draw Mohr circle. Sigma, tau. Remember, you must get a sigma from left to right hand side positive value. Tau from top to bottom downwards with a positive value. Then center is equal to here 6.660. So I put it here 1, 2, 3, 4, 5, 6. I put a little bit more, okay? Anything you do, okay? Doesn't matter how we can do these things. So from here, we can do many things here. We can draw the circle C. We can do anything here. Doesn't matter how we can do. We can put any point. Okay, we see this one is 2, 4, 6, 8, something. We can see that here will be something roughly here. The C. Okay, the C is equal to 6.3360 here, and the circle is 24 something. Okay, we can draw the circle. I didn't put anything here, okay? Just put it in a circle somewhere. Something like this. Okay? What means the radius? So this is equal to here. The A is 0, 22, something here. Okay, this A is here. Remember, 0 come to here is a positive value, come to this one. I didn't put exactly the numbers, okay? Okay, just let you know this is A, point A. Point A is equal to 0, 22.64. Okay, so that's the point A, point C. So now, of course, other thing is easy to work fast because this one is R. This one also the R. So the one from here, sigma 1 is equal to sigma average plus R. Okay? So you can see 6.336 plus R, 23.51. Okay? So that's roughly 29.9 megapascal. Sigma 2, you can see here, is from sigma average minus R. So you can see from here is 6.336 minus 23.51. So roughly negative 17.1 megapascal. Okay? So tau maxima in plant will be equal to R. So equal to 23.51 megapascal. So other thing, the angles, you should work by yourself. I will continue. Clear? So you can see this question was last year standard final exam question. Clear? So at least you should practice this question many times. You get an idea how you work sigma x, how you work sigma y, how you work on the tau xy. You can work out. So in the exam questions, we cannot just provide this one direct to you. You must work all these things by yourself to find the tau xy. So I highly recommend you guys can strengthen this question for many times. Yes, please.
In the exam, do you expect us to draw those two squares at the end as well, or do you just want the answers for the angles and the tau max and so on?
You need to do all of them.
To draw it as well?
Yeah. Okay, you should draw because I mentioned to you construct more circle and determine. Okay, so that's why you can see mid-sem time asking you please use method of a section to do this thing because that is for examination. Okay, any question about this? So everyone, please practice the question many times as you wish. Okay, you will get a lot of benefit because this is a real question in the last year. Hopefully this year we'll do that again, but I cannot tell you yes or no. But at least you can practice the real problems. Everyone clear? Get the real knowledge, get the real question problems, you can solve the problem very easily. Okay, thank you. That's for this part. But remember one thing, for this topic, we must just ask you to construct more circle. If you cannot solve all the problems, you can draw the circle, you can stick a lot of marks. Get the sigma x, sigma y, tau xy, get a mark. Center of the circle, reference point, radius, draw the circle, and get a lot of mark over here. Okay, all this is actually easy. Okay, sigma 1, sigma 2 is quite easy to work out. You can draw the circle. So in the last year, many students get a full mark of this question. So that's what depends on you. Don't start from beginning to end. You need a few minutes to find which one is easy for you. Okay? Please practice the problem as many times as you can, so you will get a benefit. Thank you very much.